we ready for today's lesson? Thumbs up. Ready, ready, ready? Yes, we're going to be talking about exponents and surds. We're going to be looking at something a little bit fun. I'm hoping it's going to be fun, but it's going to come back again next year. It's also part of the grade 11 and the grade 12 matric paper, so it will be a little bit interesting for us to see. Okay, so we're going to start with rational exponents. Now, when we look at something like this, when we say that something is the square root of x, we actually mean that it's x to the power of a half. Let me explain. So in grade 8, when we were learning about exponents and we were first learning about algebra, they would give us a question that looked like this. They would go 64 x to the power of 6y to the power of 8, and they would say they want the square root of that, right? So what this meant was we would take the square root of 64, and that would give us 8. We know that the square root of 64 is 8. And now to get x, the x value, we would keep the base, obviously. We would keep x as our base. And what we would do is we would take 6 and we would divide. Good. We would know that because this is a square root, there's actually an invisible 2 over there. And we would go 6 divided by 2, which is 3. And then we would also, oh, what happened there? Okay, that's 3. And then we would take y and we would take 8 and divide it by 2, and we would get 4. Okay, now I know that dividing by 2 is actually the same thing as a half. Are we aware of this? Yes. Anything divided by 2 is the same as multiplying by a half. Yes, thumbs up. Are we aware? Everyone okay with that idea? Yes, great. Okay, so if we look at this idea over here, I know that if I've got the square root of x to the power of 6, this is actually the same thing as x to the power of 6, all of this to the power of a half. And I know that if I see a bracket and an exponent, I'm going to multiply those two things. So I know x, I will have x, and then 6 times a half will just give me 3. All right, thumbs up. Are we all okay with this idea? Yes, everyone okay here? Should I explain again? You can put a thumbs down, and I'm happy to explain again. Shall I do it again? I can use a different example, maybe. Okay, let me try a different example. Let's see if we can get that. Okay, so if I give you guys a to the power of 4, and I say that I want the square root of a to the power of 4, can anybody tell me what the answer is going to be? The answer to that will be anybody got an answer for me? What is a to the power of, not quite, Abu. Okay, remember, there's still an invisible 2 over here. Right, good. So my answer would actually be a to the power of 4 divided by 2 would give me 2. So the answer is a squared. But let's take the square root out of it, because we know that the square root is the same as x to the power of a half. So now I have a to the power of 4, all of this to the power half. So now over here, I know that those two will multiply together, and I will get 8. And now I've got half of 4, or a, and half of 4, which will be 2. Does that make sense? Is that okay? Is everyone okay with that idea? Excellent. Okay. Now it will work again with cubed numbers, right? So if I give you x to the power of 9, and I say we've got the cube root of that, the cube root of x to the power of 9, right? That would be the same as x to the power of 9, all to the power of a third, right? So now I know that a third of 9 would just give me x to the power of 3, right? Same with x to the power of 9. I would just take x and I would go 9 divided by 3, and that would give me 3. All right. Now, we are not actually going to be using x's and y's and a's. We're going to use actual numbers today. But the idea, the concept of this is from this particular thing that we learn in grade 8 when we start. Okay. Okay, I just want you guys to note that a rational exponent is actually fractions. The word rational just means something over something else. Okay. When maths was just 1 + 1. Hello, Palisa. Okay, so the idea of a rational exponent is to get something into fraction form. Okay, so over here, where we have x to the power of 5, that's the same as x to the power of 5. All of this to the power of half. And if we multiply these two things, I'm going to end up with x to the power of half of 5 is just the same as 2.5 or 5 over 2, just like that. Okay. All right. But it's not going to look like that. It's not going to look like that. I'll show you. Let me show you the examples we've got here. Okay. Shall we start with A? Let me show you guys what I mean. If I look at A, I now have got 9 to the power of a half. Can anybody tell me how else can I rewrite 9? How else can I write 9? Remember, we're working with exponents. So how else can I write 9? Good, as 3 squared. Good, that's correct. So let me just write A over here. So I'm going to rewrite 9 as 3 squared. And all of that is going to be to the power of a half. Okay, now over here, I know that I've got a bracket and an exponent. I'm going to multiply in. So that's going to give me 3 to the power of half of 2 is just 3 to the power of 1. Okay, are we comfortable with what ma'am has just done? Yes? Yes? Okay, lovely. All right, let's look at B. Let's look at B. Okay, now I've got 16 to the power of 3 over 4. How else can I express 16? I know that 4 squared is one of them, but think of another one that has a power of 4. How else can I express 16? Anyone got an idea? 2 to the power of 4, exactly, good. So I know that 16 can be written as 2 to the power of 4. All of this will then be to the power of 3 over 4. Okay, so now my answer will be 2 to the power of 3/4 of 4. We're going to take these two and multiply them together. And I know that this was actually a fraction, so I'm going to get 4 times 3 will give me 12 over 1 times 4, which is 4. And that's going to be 2 to the power of 3. 2 to the power of 3 is just the same as 8. Okay, are we getting the idea here? Yes? Okay, I want you guys try C for me and try D. And let's see if we get a nice answer. I don't know about nice, but we should get a nice answer. Yeah. Try those out and tell me what you get for each of those. Okay, Narisha's done. What about everyone else? What are we thinking? Have we got an answer? Abu's done. Mandisa, Palisa, Gift, everybody else, how did we do? Or are we stuck still? Okay, cool. All right. Okay, so I'm going to take 81 and I'm going to rewrite 81 as 3 to the power of 4. Excellent, good. 81 is 3 to the power of 4. all of that to the power of 1 over 4. Okay, then I'm going to multiply. And now I've got a quarter of 4 is just going to give me 3 to the power of 1. So my answer for 81 to the power of a quarter will just be 1. All right. Then for D, let's look at D. I know that I can rewrite 27 as 3 cubed. 3 cubed to the power of 2 over 3. Now, I know that this isn't going to be as simple as that one. So I'm going to take this 3 over here, and I'm going to rewrite it as a fraction. I'm going to rewrite it as 3 over 1. And then I know, how do we multiply fractions? We multiply the top with the top and the bottom with the bottom. That's all we need to remember. So now I've got 3 to the power of 3 times 2 will give me 6 over 1 times 3 is 3. And therefore, my answer should be 3 to the power of 2. And that is just 9. Okay, how did we do? Are we okay with that idea? Yes? Excellent. Okay, I'm going to give you guys a chance to try E and try F. Now, have a real look at F. Okay. Or maybe let's do G as well. Okay, have a look at F and G. They're a little bit trickier, but try them out before you start going, oh no, ma'am. Oh no, ma'am, what? Okay, it's all good. Oh, I see, Balisa. It's okay, my darling. I am recording as always, so you can always catch up when you can. Okay, or maybe do you want to quickly hop out and then restart, I don't know, your router maybe or something, and then hop back in and see if that helps? Just my camera's not in the right place. All right, Balisa, let's see if it helped. Hopefully you can keep up with me as we're going. Okay, Narisha's done. Everyone else? Okay, Mandisa's also done. I don't think Balisa would be done. Abu, Gift, how did we do? Because Balisa just joined us again. Did we manage? I kind of like this one. Okay, good. That's good. That's a good sign. All right, let's start with E. All right, so for E, we know we're going to rewrite 32 as, as 2 to the power of 5, right? And all of that will be to the power of 3 over 5, right? And then again, I'm noticing this one isn't going to be as easy, so I'm going to rewrite that 5 in there as a fraction. So this is going to be 5 over 1. So that's going to be 2 to the power of, and then we're just going to multiply the top, multiply the bottom. 5 times 3 will give us 15 over 1 times 5 is 5. And this is going to be 2 to the power of 3, which is equal to 8. Okay, simple as that. All right, for F, okay, F is a bit tricky. I know that we're going to get a negative answer. We should get a negative answer because that's negative 1 over 3. But the rules don't change. We're going to do the exact same thing. So I'm going to get 64 is going to be 2 to the power of 6. All of this to the power of -1 over 3. Okay. Now, this is going to give me 2 to the power of, if I change this into a fraction, if I change this into 6 over 1, I can do that. I'm going to get 6 times -1 and 1 times 3. So on the top, I'm going to get -6 over 3. So my answer will be 2 to the power of -2, which is technically actually 1 over 2 squared, and that is 1 over 4. Okay, did we manage with that one? Yes, thumbs up. Did we get 1 over 4 as an answer? Yes, no? No one? Okay, no, it's fine. No, it's okay. It was a tough one. I'll tell you that. It was meant to be tough. Don't stress. Okay, all right. Let's look at G really quickly. Now, G again, I'm realizing I'm gonna run into a problem because somewhere this 1 over 27 needs to be written differently. So what I'm going to do is I'm going to take that 1 over 27 and I'm going to first change the 27 into 3 cubed. So I'm going to get 1 over 3 cubed, all of this to the power of 2 over 3. And now what I want to do is I want just one number. I don't want 1 over something. But I know for a fact, if I have x to the power of -1, that's the same as 1 over x. Yes? Thumbs up. Are we all aware of that? Yes? No worries, Desmarie. Good. So what I'm going to do is I'm just going to do this in reverse. I've now got 1 over x. So I'm just going to change 1 over x into x to the power of -1. All right. So at the moment, I've got 1 over 3 squared. So I'm going to change 1 over 3, 3 cubed. I'm going to change that into 3 to the power of -3, all to the power of 2 over 3. Okay, and then I'm going to rewrite this as a fraction, and I'm just going to multiply the top of the top and the bottom of the bottom. So I'm going to get 3 to the power of -6 over 3, which will then give me 3 to the power of -2, which is 1 over 3 squared, which is 1 over 9. Okay, so that's the answer we should get there. Okay. Good. Okay, excellent. All right, I want to see if we can work our way backwards. Okay, let's work our way backwards. And we're only going to do these 2 questions. Okay, just these 2 questions. After that, we're going to look at something a little bit simpler. Okay, so here's what's going to happen. I know it says here, simplify without using a calculator. Okay, I'm going to ask you guys to pick up your calculators. Okay, I'm going to ask you guys to pick up your calculators. I'm realizing now that 625 is a really big number. It's a big number. Well, technically, it's just 5 to the power of 4, but that's beside the point. Okay. Gift just put it in his calculator. All right, Gift, what answer did your calculator give you? Pop in the chat what answer your calculator gave you for this. Equals. We weren't supposed to. Okay, for those of you who have not put the answer in the calculator, I want you guys to do this for me. Punch into your calculator, 625 equals shift fact. So we're going to rewrite 625 as a product of its prime numbers. Tell me what we get for 625. So give me the prime factorization. 625 equals shift fact. What do we get? Good. We get 5 to the power of 4. Oh, I don't know about 21,43. We should get an easy round number. Okay, good. So we know we're going to get the 4th root of, now inside here, I've still got 5 to the power of 4 over, I know that 81 can be rewritten as, I need somebody to just punch 81 into your calculator for me. Three to the power of 4, that's it. Oh, we should know that one actually. 3 to the power of 4, and all of this is to the power of 3. Okay, Now we're just going to distribute. Remember, we're still looking for the fourth root of, okay, now over here, the 3 will distribute to the top number and to the bottom number. So we're going to have 5 to the power of 12 over 3 to the power of 12 because we're multiplying, right? Good. Now, remember, this is the fourth root. I know that I can rewrite the fourth root as 1 over 4, right? Because the same way the square root of x is x to the half, that means the fourth root of x would just have to be x to the power of 1 over 4. So we're going to rewrite it like that. Okay, so we're going to take this and we're going to go 5 to the power of 12 over 3 to the power of 12. All of this to the power of 1 over 4. I just want to check. Is everybody okay with what ma'am has done here? Yes? Thumbs up? Okay, cool. And then we're just going to distribute again. Okay, multiply in, multiply in. Okay, so I'm going to have 5. A quarter of 12 is 3 over 3, and a quarter of 12 again will just be 3. So this answer here, 5 to the power of 3 is 125 over 3 to the power of 3 is 27. Okay, we okay with that? Yes, everyone okay there? It just takes a while for us to get there. Okay, and it's a little bit more complicated than I thought, actually realize. Okay, here's what I want to do. I want to skip B. I feel like B is super, super complicated. Okay, I'm going to give you guys some easy examples to try because I actually want us to get into surds. I think surds, yes. It does look a little bit like a war crime, I'll admit. Okay, surds are a little bit more easy to understand than rational exponents. Okay, and I don't think I'm giving it the amount of time it deserves, because when you do rational exponents at school, your teacher's going to give you like 4 to 5 lessons, and I'm trying to do that in 30 minutes. That's really not going to work. Okay, so let's do these examples. I want you guys to write the following without a root sign. So I want you guys to change the fourth root. Okay, it's fancy for maths. Okay, I want you guys to write the fourth root of a to the power of 6 without the root sign. Okay, are we able to do that? Do we know how to do that now? Yes? I'm going to remind you guys that the square root of x is the same as x to the power of a half. Okay. Okay, I'm going to give you guys some time to do A, B, C, D. Actually, we can do them all. They're not that difficult at all. Okay. I'll give you guys about 4 minutes. As a matter of fact, I think I just gave you guys the answer for F, which isn't funny. Okay, we can skip F. I already gave you guys the answer. Mm. 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 It won't, Abu. It will not. You'll survive. As does every student. We all survived. Okay, 2 more minutes and then we'll get started. Or seeing as Narisha's already done, maybe a minute and a half. If you work hard, Abu, you will. One minute left. Okay, let's get into this. Now, I just want to note, I think maybe I didn't explain something quite as easily, and this would make this a lot easier for us to get to if we understand that the reason why ma'am writes x to the power of half over here is because we know that there's an invisible 2 over here, and the exponent of x over here is actually 1. So when I write x to the power of 1 over 2, it's because I've taken that exponent over there and I've divided it by that exponent. Does that make sense? Yes? Thumbs up. Are we okay with that idea? 1 divided by 2. And that's how ma'am gets the half of that. Okay. So when we get the answers to this, we're just taking the exponent of the thing on the inside and dividing it by the exponent or the root on the outside. Okay, so if I take a, I'm going to get a to the power of, I'm going to take the number on the inside, 6 over 4. That's the final answer. Or I can actually simplify this a little bit more. I would rather not, because they actually wanted the 4th root, so we're going to leave it there. Actually, no, we should. A to the power of 3 over 2. We should always simplify fractions. No, Narisha, did it not work out that way? I'm sorry, I'm realizing I'm not being the best teacher at the moment. Yeah, it should be a to the power of 6 over 4. All right, let me ask this. Who can give me the answer for B? What would B then be? What would we get here for that one there? We would get x to the power of something over something. What would I get? Five over 3, that's it, good. So this would become x to the power of 5 over 3. Easy, easy things. Okay, if we look at this one over here, we know that there's an invisible 2 over there. So for C, we would get a to the power of 5 over 2. For D, we would get x to the power of 3 over 4. For E, we would get a to the power of 2 over 3. And I'm not going to do F because I already gave you guys the answer over there. Okay, all right. I'm going to stop rational exponents here. Okay, it's a complicated concept that I cannot cover in 35 minutes. It's not going to do the things. Okay, can I introduce us to something a little nicer? Something a little bit more, a little bit more nice, something that we can actually punch into our calculators and get a good answer for. Yes, let's do something a little bit more fun. Okay, these are surds. Okay, we've heard the word surd before. Yes, have we heard the word surds before? Thumbs up if you have. Oh, Abu, that's perfect. You're not going to need a calculator. Okay, Narisha says, somewhat. Mandisa, have we heard the word surd before? Nomusa? Palisa, Narisha, have you heard it? Okay, excellent. All right, so when we talk about a surd, we are talking about a number that sits underneath a square root or underneath a cube root that isn't quite a perfect square or a perfect cube, right? Like for instance, if I gave you guys the square root of 4, what is the square root of 4? We should know this. This is an easy question. We should all kind of know. Yeah, the answer is 2. It's not that complicated. So 2, or the square root of 4, is not a surd. This is a perfect square, not a surd, right? But if I said to you guys, what is the square root of 3? What is the square root of 3? Yeah, now it looks ugly. We get decimals, we get multiple, like recurring decimals. It just means that it's not a perfect number. It's like an irrational number, right? So it's going to be something like 1,73, and it goes on and on and on and on forever. So if it is not a perfect square, it is automatically a surd. So this is a surd, and that is not a surd. Make sense? Should I repeat that again? Okay, let me put it this way. Irrational numbers, okay, irrational numbers under, sorry, or let's say this, yeah, numbers under a square root that are irrational. Okay, because when we get the square root of 3, we get something like 1,731, and it goes on and on and on forever. This becomes an irrational number. This makes the square root of 3 a surd. This is a surd. Let me ask you now, if I said to you, the square root of 5, is that a surd? Is that a surd? Yes, good. It's a surd because it's going to give me, if I punch in the square root of 5, it's going to give me an irrational number. What about the square root of 16? Is that a surd? No, it's not a surd because the square root of 16 is 4. That's a perfect number. So it's not a surd. So surds are numbers that sit underneath the square root sign that are going to give us an irrational answer. Do you get what I mean? Excellent. Good. All right. So we are going to be looking at something called, we're going to be simplifying surds. And it's kind of nice if we look at the example that I give you over here. Okay, so I want you guys to do this for me. Or this is a pretty easy example. We all know, what is the square root of 100? We all know that the square root of 100 is, we should know this, easy, quick maths. Is not a surd. Good, it's 10. It's absurd that the square root of a perfect number is not a surd. But okay, all right. So I want you guys to pick up your calculators if you do have one, and I want you guys to punch into your calculator the square root of 200. Tell me what your calculator says. What does your calculator say when you put in the square root of 200? Good. Now your calculator says 10 root 2. Okay, do not Google, Abu. We need a calculator for this one. Okay, now it says 10 root 2. Okay, you're going to need a calculator. All right, okay. Now, I want us to notice the differences and the similarities here. So when we put in the square root of 100, we get just 10, right? But when we look at the square root of 200, what our calculator has done is it's taken out the square root of 100 and it's left the 2 that was multiplied to 100 underneath the square root. So it's taken out the perfect square and it's left behind a surd. Do we see that? Yes? Pretty cool, huh? Okay, let's try another one. When I leave only the crust. Yes, it's like when you eat a pizza and you leave behind the crust. This is basically what's happened. Okay, let's try this. Okay, so we all know that the square root of 4 is 2, right? But what about the square root of 8? Punch that into your calculator and see what your calculator says. It says 2 root 2, right? It says 2 root 2. So what your calculator has done is it's taken 8 and it's split it into the perfect square, which is not a surd, and it's left the surd inside the square root. Yes? Okay, so let's figure out exactly how we can do this without a calculator. Right, so if I've got the square root of 50, like I've written over here, if I've got the square root of 50, I know that inside the number 50, there is a surd and there's a perfect square. There's a perfect square in here. Let's think about it. Which number or which two numbers make up 50? Think of a perfect square that makes up 50. Can anybody think of one? Just go down the list. It's not 1, or it could be 1, but that would defeat the purpose. It can't be 4. Good, good. It's 5, right? It's 5. So what I'm going to do is I'm going to do this. I'm going to take 50 and I'm going to split it into 25 times 2. Right, 25 times 2 is 50. And then all I'm going to do is I'm going to find the square root of 25 and take that out of my bracket. I'm going to take that out of my, not my bracket, my square root sign. And I'm going to leave the third inside the square root. So this then becomes 5 root 2. And you can try that on your calculator and it'll come out perfectly. All right. Really cool, huh? I like that one. Okay, let's think about how we can rewrite 32 underneath the square root sign so that we get out a perfect square and a third. What number are we looking for? Tell me what to write underneath the square root, guys. Good. We can write 16 times what? 16 times 2. Good. And then we're just going to take the 16, the square root of 16, out of my root, and I'm going to leave behind the third. So I'm going to get 4 root 2. This must be so much nicer than rational exponents. Yes, it must be so much nicer. Yeah, I know. It's just that in your textbook, rational exponents comes first. So we need to do that part first. Okay, and it's a little bit complicated, but it all ties in together. All right. Okay, can I give you guys some examples to try on your own? Yes? Okay, they're not always going to be this simple. We're not only just going to get a square root 2. Sometimes you really need to go down the list and really think about it. Okay? But here are some examples. Okay, we can maybe stop halfway. Let's do A and B and C and D. Let's stop there. Okay. Pop an emoji on the screen when you're ready. No, we should not get a decimal. Remember, Narisha, we don't always have to take out 2. Okay, so you don't always have to try times 2. Try another number. Maybe take out a 3. Let's see. Can we get 45 equals something times 3? Because the square root of 3 is still a third, right? Or, okay, I can't use 4 because the square root of 4 is a perfect square. Maybe the square root of 5. Okay, so it doesn't always have to be 2. It could be a different number. As long as the number that we have left underneath the square root is a third. Okay, so try other numbers. Narisha's a bit stuck. Can I just check? How many of us are stuck and need a little bit of help? Yes, just put a thumbs up on the screen if you need me to help you a little bit. Okay, Narisha's stuck. What about everyone else? Are we doing okay? Okay, Narisha, I'll help you out. Okay, let's start with A. Okay, so I know that I need 45 to be split into a perfect square and something else. Okay, I know 3 times 15 is not going to work. Neither of those two numbers is a perfect square, right? I can't use 4. 4 is an even number. That's not going to work. But what about 9 times 5? Does 9 times 5 not work? Yes, it works, right? Because I know that 9 is a square, is a perfect square, but 5 is not. 5 is a third. So I'm going to take out the square root of 9 and put it outside, and that's going to give me 3. So this is equal to 3, and what's left underneath the square root? Our third. Okay. The square root of 5 is what's left. Okay. Remember, the number that we get out on the other side just needs to be a third number. Okay. All right. Do you see the idea here? So it doesn't necessarily always have to be something to the square and the square root of 2. No, it could be something in the square root of 3, because the square root of 3 is also a third. The square root of 2 is a third. The square root of 5 is a third. The square root of 6 is also a third. Because 6, we can't find the square root of 6 without it giving us an irrational number. Okay, so think about all the different ways that we can combine it. Does that make sense, Narisha? Are we okay with that? Good, excellent. Okay, try B. Try B, try C, try D. Go down the line and see which numbers you can pull out of there. Okay. I hope everybody else is doing okay. Yes? Okay, I'll give you guys 1 more minute, less than a minute, and then we'll chat. Yay, that's good. That's amazing, Noosa. Well done. Yeah, look at you doing grade 11 maths like a pro. Nice one. Very well done. Okay, all right. Shall we have a look at the answers? Let's look at B. Okay, let's have a look at B. So B, okay. First thing I used to do. So when I was in school, these were actually quite difficult for me because I couldn't wrap my brain around what kind of thing are they asking me for. So what my tutor at the time told me is just start with the third, because you know that you're going to end up with a third. So what I first used to do is I used to go, okay, I've got 125. If I do 2 times nothing will go in there. Right? Then I could do 3 times 25. That's 75. That's not going to help me. So 3 is not going to help me. So maybe I try 5. I can't do 4. Does everybody thumbs up? Do we understand why ma'am can't go 4 times? Yes? I can't do 4 because 4 is a perfect square. It's not a third. So I'm going to skip 4 and I'm going to go to 5. So I'm going to go 5 times 25. 5 times 25 will work. Good. Because now I know that 5 is a third and 25 is a perfect square. And then I'm just going to pull 25 out, and therefore my answer will just be 5. And what I have left underneath the square root is the square root of 5. Okay, that's B. Right, let's go to C quickly. Let's see, I've got the square root of 48. Okay, it is quite easy. I'm glad. All right. So I'm going to go, this is equal to, okay, I'm not going to write the square root of 48. We already know it's there. So I'm going to go the square root of, I'm going to get 2 times 24. That's, no, none of those. There's no perfect square there. But I can get 3 times 16. That's helpful. I know that 16 is a perfect square. So that goes outside of my bracket. The square root of 16 is 4 root 3. There we go. Okay, that's C. And let's look at D really quickly. I'm just going to scroll up a little bit. D. Okay, I've got 175. 2 times, I know that 2 is not going to work. 3 times, so something, I don't know. Does anybody have an idea? 3 times what equals 175? No, it doesn't work, right? 3 times, I can do some quick math. Let me do quick math in my head. 15, so I'd get 55. I would get 3 times 55. That doesn't help, right? And then I could get, I can't use 4. 5 times what will give me 175? 5 times 35, so that's not going to help me. 6 times 6 is definitely not going to work, right? Because 6 times, let me see, how many times? 5 root 35, 25 times 7, that's it. 6 is not going to work, right? But remember, and let me just see who posted this. Remember, Palisa, 5 and 35, neither of those two things, none of them is a perfect square. One of them must be a perfect square, so it can go into that. And Narisha, that's exactly what we're going to talk about in just a second. Okay, so one of them has to be a perfect square. If you look at Mam's answers above, that's 25 there. 25 is a perfect square, so it comes out. This is 16. That's a perfect square that comes out. Over here, we've got 9, perfect square that goes out. So we always need to have a perfect square somewhere. So 175 is the same as 7 times 25. There's my perfect square. So 25 will come out, and my third will be root 7. So my answer will be the square root of 25 is 5 root 7. Okay, do we want to try the rest of these? Do we want to try 3, E, F, G, and H? Yes? Okay, I'll give you guys like 5 minutes. No, 5 minutes is a lot. I'll give you guys 3 minutes. Okay, try E, F, G, and H. I feel like Nomusa's really enjoying this. She's having the time. She's having a time, but go for it. Okay. Yes, Narisha, that's correct. So I'll tell you guys about the cheat code. I'll tell you guys about the cheat code in just a little bit, but Narisha's figured it out because that's how we do it. But the thing is, most of the time when we say simplify, it's without a calculator. So you can't go straight from this to the answer. You need to do the calculation in between. Okay, but if you do it that way, it always works, and I'll show you. Okay, I'll show you how my mentor teacher taught me how to do it. Okay, but let's finish up really quickly. Researching. It's all good. It's all good, Abu. You can do this in your head if you're quick enough at grade 5 maths. If you're really good at multiplying. Ah, Sia's got it. Okay, cool stuff. Okay, 1 more minute and then we'll have a look at the answers. Wonderful, Narisha. Excellent. Okay. All right. That's timed. Okay. Let's have a look at these answers really quickly. Good. Okay. Let's look at E. All right. If we look at E, we know that we're going to take 3 times 100. We already know that 2 times 150 is not going to work. None of those are perfect squares, but we already know 3 times 100 will work. 100 is a perfect square. So we're going to take 100 out. The square root of 100 is 10. So we'd get 10 root 3. Okay. And then let's look at F. F says 28. So I know 28 is 2 times 14. None of those things are perfect squares. 3 is not going to work because 3 doesn't even divide into 28. If we try 4 and 7, good. 4 times 7, that will work. We have a perfect square. So I'm going to take 2 out. Oh, wait, I don't know what just happened. Sorry, guys. I don't know what happened there. Okay, if we take 4 out, we get the square root of 4 is 2. And underneath the square root side, our surd is 7, or root 7 rather. Okay, so for G, 72 can be rewritten as, just remove that. 72 can be rewritten as 2 times 36. And I know that 36 is a perfect square. The square root of 36 is 6, and our surd is root 2. And for H, okay, I know that 162 can be rewritten as 2 times 81. 81 is a perfect square, so that's just going to be 9 root 2. Okay, and there are the answers that we get. How did we do? Did we manage? Yes, thumbs up. Did we manage? Did we do well? I quit on the last one. That's okay. That's okay. All right, let's learn the cheat code really quickly. Let's learn the cheat code. Okay, I'm going to use E as an example because it's nice and easy. So E says we need to simplify the square root of 300. So now what you can do is you can pick up your calculator and just punch in the square root of 300. Because as soon as you click equals, your calculator is going to do this. It's going to go equals 10 root 3. Okay, now the problem is if you do this in a test or an exam, we're going to know you've used a calculator because you've skipped the middle step, right? So if you notice very carefully, ma'am has left a space there, right? So if you do this on in your test, we're just going to be like, this person used a calculator, no mark. 0, no mark. But because we work our way forward, yes, Sia?
We're going to make 10 to the power of 2 there in the middle.
That's it. Good. We're just going to return 10 back inside by doing the inverse operation. Nice one, Sia. You figured it out. So we're just going to, in this space over here, we're just going to take 10, put it back inside, which means it's squared, and that makes it 100 times 3. Well done. Excellent. Good work. Okay, so we can do this with all of them. So F was the square root of 28. If you punch that into your calculator, you're going to skip a line. Your calculator is going to go straight to 2 root 7. So over here, you're just going to open up a big square root, and then you're going to take 2, put it back into the square root, but because it's being put back in, it was squared. So underneath the square root, you will just have 4 times 7, just like that. Okay. And that's a very nice cheat code to know. You can go brag to your teachers next year, or